Welcome to Uptime Spotlight, shining light on wind energy's brightest innovators. This is the progress powering tomorrow.
I am here with Eric van Genuchten. So Eric is the COO and co-founder of Sensing360, and they are bringing optics to monitoring for gearboxes, other rotational equipment. We're going to talk a little bit about what that means for the wind industry today, implementation, retrofits from the factory, all kinds of good stuff. So, Eric, can you give us a little bit of your background? What makes you an expert in the space?
That's a good question. So basically, my background is I studied physics when I was much younger than I am now. So I'm not going to disclose when, but I've been working since roughly 20 years. And I have a background at SKF in the bearing manufacturing space. And basically, I've been working within SKF as condition monitoring solution developer. So I've been in condition monitoring for almost 15 years now. And from SKF, where we developed condition monitoring systems for all kind of applications, but also wind, of course, we went towards load sensing of bearings to be very specific to help our large customers. And for that, we used fiber sensing. And 7.5 years ago, I started with two colleagues. I started Sensing360, which is the 360 is, of course, the rotation, but we are using fiber optical sensing or optics for rotating equipment, mainly bearings, large bearings, gearboxes. And we have been focusing a lot on wind the last 5 years, mainly on the planetary gearbox, because that's a challenging part from the rotating system to monitor. So that's where we think we can add some value.
So I know, I want to share this with the users too, or listeners here too, because I came across your technology 3, 4, or 5 years ago or something over in Europe. I think we were in Copenhagen, Wind Europe in Copenhagen. And I remember seeing you guys in like the startup space, and I walked over and you had like basically what looked to be a stainless steel bearing race on the table with your sensor package on it and a live readout. And I looked at it and I went to pick it up and I was like, this is interesting. And when I picked it up, just my hand on it, I looked at the screen and I could see all the deflections happening on the screen from just me grabbing this. And I mean, you remember what the product thing there was. It was probably 4 millimeters thick of stainless steel. Like I'm not squishing that thing with my hand, but you could see it.
Yeah, I know. A lot of people checked if we had a camera around it to see if they were mimicking the moves. But basically, yeah, if you ring about it, it's this product still. We still have it. It's still operational. And this is the type of bearing, a small, relatively small one for let's say wind. But it's a 22 kilotons of bearing, and you can still see the pinching of your arms. So indeed, and that's basically what we do. We integrate our sensors in steel and make, I don't say stupid steel smart, or if you put it around, we made rotating equipment smarter, if you rephrase it basically.
I like that. So, in the wind industry, if you talk about the past was when blades were shorter. Of course, now everybody's worried about blades. That's what we hear all the time. But when blades were shorter and more robust, the problem was gearboxes. It was, what are we doing about this rotating equipment? We're having failures. This is a regular thing. We've gotten a little bit past that with better bearing technology, more iterations of gearboxes, different things of this sort. But there's still issues out there. But this is your mission statement, right? So can you describe the problem of basically what you guys see in the field and what you're trying to solve?
Yeah, so the problem in the field, what we see with gearboxes specific, and also what has been accomplished with several OEMs, because we like to work with customers, because that basically brings the real problems outside, is still, and it's valid for all slowly rotating equipment, but it's still, if it's slowly rotating, there's a lot of energy to do the more classical vibration monitoring. So you have a challenge to predict failures. And that's what we're still focusing on, eliminating failures. So let's say in a main bearing, they get 99% of the failures by vibration monitoring. In the high-speed shaft bearing, they get the same amount. But in the gearbox, they get 90%. So there's still 10% of failures they cannot detect. And planetary gearbox failures are pretty catastrophic. They are, let's say, huge replacements, cranes, downtime. So yeah, we want to predict it better. And secondly, like all rotating parts basically do, you translate the rotation to the fixed world, and it's as we say, or used to say, the bearing is not the victim, is not the cause, but the victim of a failure. It is. You can derive almost all your running conditions from that single point of measurement. So operation conditions, misbalance, unbalance, wear. So you can make predictions about this is my statement, prediction about this is the driveline. And of course, as you mentioned, a wind turbine is not only a driveline, the weakest link kind of defines the total life, but the driveline is an essential part of it. So it's still a complex system to monitor with current vibration monitoring, and we add basically load and strain sensing towards it. Therefore, we do better predictions.
Yeah, because I mean the answer here is, or the what we're trying to arrive at is we want to have early prediction of what would be a failure, right? Because we want the up tower repair. We want the 20, 30, 40, $50,000 repair versus the $300,000, $400,000 repair where you're replacing gearboxes or planetaries or all kinds of things of that sort. So the technology that you guys have, of course, you're using fiber optics, which you can arrive at a much more finite measurement. Can you explain how that works? I guess let's take the first side of it. Let's explain how it works if it's integrated, say, from an OEM standpoint.
Yeah, so if it's integrated from an OEM standpoint, and we're working with two of them, and there's not that many. So basically, when you integrate it, you put it directly on the outside of the ring gear. So the freely accessible side part of the system, and it's directly put on the outside. And as you mentioned, you can integrate more very sensitive sensors. And due to the fact that you have more sensors and that they are so sensitive, you can distinguish between temperature, loading, misbalance. So you have more information than just one basic strain gauge. So we integrate it on the outside. Then basically when the planets are rolling, so you have the planets and you have the sun, the planets are rotating, it presses basically the steel away and we measure that. And that measurement can be done integrated at the OEM, and then you get a smart gearbox basically, which measures torque and load sharing and used for prediction. Even as you mentioned, to prevent the small up tower repairs, or to prevent the big non-up tower repairs, but do the small up towers repairs, and even winning time if you have to replace it anyways. The whole logistics saves a lot of money and time if you know it 6 months up front instead of 2 weeks.
So speaking of OEMs though, right? Because of course, WeatherGuard here, we're an aftermarket product company, and we speak with OEMs about integrating from the factory level and those kind of things quite regularly, as well as operators, right? You're starting to see operators put aftermarket solutions that they've deemed to be good in their turbine supply agreements or in their turbine RFPs. Hey, OEMs, we want this. You guys are working directly with OEMs. It's a tough thing to do. Congrats on that, right? So what are they using it for? I mean, of course we know sensing, right? But if it's an advanced thing, it's not on every turbine. Why your system? Why are they using it?
The two main reasons to use it, maybe I have to make 3 reasons to use it, is the main reason is that there's now a trend towards journal bearings. They're cheaper, they're essentially longer life. So in the planets, there's a different type of bearings, which are not possible to monitor with vibration sensing, and we are able to monitor by looking at the load changes over time. That's the main reason, extra condition monitor, better condition monitor. And secondly, I think gearbox OEMs also want to extend their, let's say, piece of the puzzle or piece of the cake. They want to become more important, so they become more digital. I think you have seen the platforms both by 360 or Thrive, and they want to do the digitalization. But in the end, to provide extended warranty, because that's what their customers are asking for. And you can give extended warranty if you know what happens with your system. And that's why they use it. They use it for the real operation and usage monitoring of their gearbox.
Well, I think that makes sense, right? If you're trying to extend a warranty period, or like, I guess for a gearbox manufacturer, they get to sell an extra bit of warranty, right? So they're happy with that. But you were getting closer and closer to, and I know this term always kind of bothers me. It's like when people say, oh, this is AI. Well, it's not always AI. Sometimes it's machine learning. Sometimes it's algorithms, whatnot. But when we get closer to that term of a digital twin, you guys are making progress towards getting the industry at that level for slowly rotating equipment, or quick rotating equipment. Is that part of the marketing sales pitch from Sensing 360? Is the digital twin, or what does it look like?
Yeah, so it's input for the digital twin. So basically, we provide information for data teams to make a digital twin. And it's nice that you say that, because I mentioned already, we measure torque or loading, and 20% more loading on a gearbox or on a bearing is half of your life, and the other way around. 20% less loading is double your life. So if you have a digital twin, the crucial part is what is actually the operating to do any scenario planning or maintenance planning. So we provide the information for the digital twinning. We don't make the digital twins. We might if we grow, but at this point not.
I like the idea, right? Because when you hear a lot of times like, oh, this turbine has this issue, let's derate it, right? We'll derate it for this amount of time, or this part of its life, or even if we're into a lifetime extension scenario, we're going to derate it for the rest of its life. That happens. It's happening around the world. So, but actually having knowledge and having information and data, hard data, and I stress this with everybody. And it's not just a wind industry problem, right? It's an industry problem, quantitative data versus qualitative data. But I stress quantitative data. So now you have the ability to produce that. Hey, you're reducing loads by 17% or 22%, whatever that may be, and the lifetime extension could look like this. That's an important part of furthering the wind industry as we get to aging assets, especially here now in the States, as we see this last one big beautiful bill thing changing our ability to do PTC driven repowers, right? Which was like, run this thing hard for 10 years because at the year 11 we're going to repower. That's not a reality anymore over here in the United States. You know, who knows what could happen in 4 more years or 8 more years, but right now we're switching operational strategies, O&M thought processes to how can we get a lifetime extension out of this? So let's speak on that a little bit. You know, you guys are integrating from the factory. Great. Now, fantastic. However, retrofit. What does retrofit look like?
Retrofit looks the same, I would say. We still integrate it on the outside of the ring gear, even on the outside of the paint, by something we call a sensor strip, which it takes an hour to install, basically, up tower. And then you have the same data as you had from the factory installation. Of course, you need to think about, will I do with magnets? Will magnets live for long enough? That's always, is it acceptable? Blah, blah, blah. But that gives the same load data. Now, the good thing about a wind turbine is, of course, that it runs at rated power most of the time. So you can derive a calibration while running in situ. So you don't need a whole kinds of high-level simulations or other thoughts to solve it. But looking at that, we measure for a month as an example. And then you get the torque levels, the load levels, the curtailment stops, the start stops, the brakes. And we get all these effects. And every day you make a statement like, I've used this much life according to the load I had and to the time I was running. And that counts to a used capacity. Of course, you have to go back to make an estimation about the future, but you basically take a period of 3 months and you go back and forward with it with the same regimes. You can say, well, based on what we have known now, there are 6 years left in this park. And then you talk about extension. If you have multiple turbines, you can play with load balancing over the turbines to take the hard ones to reduce their loads and take the ones who have, based on the data, seen less load, take them a bit more load. So you can kind of maximize energy output. At least you have the information to do so. I don't know if park owners are fully equipped to do it, but that's one of the input parameters you can use to do extension.
Well, that leads me to another question here. So Sensing 360, of course, you guys create the technology, the hardware, the sensors, and a software platform to look at the data. But are you guys providing those operational insights, or is that part of your business model to say, hey, you should do this or you should do that? Because one of the problems we see in wind, and we talk about this all the time, is tons of data. We've got big data, big data, big data. What do we do with all of it? And at the same time, you're seeing engineering staffs shrink, some layoffs and things like this. So they're losing some internal resources. Is this something that you guys can help people with as well?
Yeah, so our solution gives a recommendation. So in the end, we don't own the park, so most of the time not allowed to do any control on it. But it makes it, and I like to say it, and of course I would like to say that, but it makes condition monitoring basically one side simpler and also the information more dedicated. So you need less of a degree to analyze it, because if you are in the vibration space, looking at vibration spectra and analysis and making the correct conclusion is still a science. It's still quite some. And of course, AI is increasing there and we can look at anomalies, but you still physically need to understand it to make a good estimation. That is what since we have both usage and vibration monitoring, we both have, let's say, we have both information at one point. So we use that to make it simpler. So also run-in times are a lot shorter, basically. And secondly, a statement like you have 6 years left is a relatively simple statement, but even financial people can translate into this is my cost over time. So yes, that's our goal. And we give recommendations and advices. That's still the case, unless they want me to control their park. So I would love to I would love to build a business model, Joel, with I get extra production I get paid for, and at least production I don't get paid for. But I'm not there yet.
I like that. Okay, so I'm gonna ask a couple questions then, I guess, from an operations standpoint. Say I am wind farm owner XYZ, and I have 2 parks, and one of them I've been losing some gearboxes in, or I'm getting towards, a lifetime extension type thing. What does my journey look like if I call Eric and team and say, hey, I would like to monitor these things. I need more insights of what's going on in my rotational equipment. What does life look like for me if I'm trying to implement the solution?
They never immediately start buying everything for the whole park, which is understandable because we are not like the big, huge condition monitoring company. So there's still some trust issues, I would say, but basically it starts with an assessment. So basically we have now developed a tool, a suitcase where we will go up. We will put our sensor there with magnets, measure for a day or an hour, and then say, okay, this is what we can gather, this is the information, and this is what we can see now. We do that on 1 turbine and preferably 3, 4. If you have a park with problems, it's slightly different because then they know the problems we had in the past we cannot see with our current system. So we're gonna instrument several of them and look together at the data because we have kind of proven that we can pinpoint teeth breaking, bearing failures in the plant. So we have a story. This is working. If we go about lifetime extension, that's still, the proof is still in the pudding, let's say, or the proof is in the eating of the pudding. That's still going together, look at this data. Okay, we can see now last month with this one wind turbine, this is the status, and we see you have 6 years left. And then you slowly go to 2 turbines, 4 turbines, whatever turbines. That's the story, I think.
Okay, when I look at the solution from the outside, I think, oh man, this must be difficult. But it seems like you guys have come with the hardware solution that's not, right? Magneting onto the outside of the planetary is pretty freaking simple. Deploy a couple systems on a couple of different turbines. If you are leaving it, now I want to get a cybersecurity question. If you're leaving it behind, what does communications and power look like up tower?
That is a good one. So basically, you put on the sensors, and you have a small computer box, which both gets in the light, reads the light out, and does the calculation. Then there is the most classical way is to put it directly into the current systems, SCADA systems, monitoring systems, which you already have, which have the security there, and also are managed on this security level, and the data goes to the customer portal. That is the integration with current systems. Then parks with problems, especially older parks, do not always have condition monitoring systems. And then you need to indeed find either a 4G connection, 5G, Starlink, there's many options. And then there's a secured connection towards our cloud, according to the latest standards. It depends per company, indeed, what are the demands of your securing systems. But we have, for instance, we know that there was a huge hack at Nordex, and so they have improved their security levels, and we meet those So that's basically currently there, but it will remain an ongoing work evolution of what is secure, what's not.
Yeah, it's continuing to change all the time, and I think you're starting to see people get more stringent, right? I've even had things where I've dealt with clients sending them an email and they're like, "Whoa, whoa, whoa, we have to look at your email processes." Like, what? This is a bit ridiculous. Um, but let me go to another question. So this is a big one. You're working, so I want to give a little track record for the company. You're working with OEMs. So you're integrating things from the factory. Again, kudos on that. That's difficult to do. You're doing retrofits, multiple different styles of gearboxes for different manufacturers. How many wind farms are you guys on, or how many turbines are you guys on out in the field?
I hope to reach the 50 by the end of the year, but we're currently at 35 turbines.
Yeah, kudos to you guys. I think it's a difficult place. That's a difficult hurdle to cross, right? From a startup with a bunch of really smart technology and smart people creating a product, getting it into the market, and then starting to expand. The fact that you've done it with OEMs already, again, difficult. So good work on that. Eric, what other message would you like to get across to the wind industry about their gearboxes? What do they need to be doing? What's the best practices from Eric's seat?
So there's a statement from one of our earlier cooperators, which was Siemens Gamesa. And he said it would be ridiculous with the increase of complexity and value of a gearbox to not instrument them with fiber optic sensing, which is a statement, of course, I would like to bring out. And basically, it is. If you start integrating a couple of €100 of sensors in a gearbox, which is the 500,000, I have no idea, but in those ranges, and failures are up to 2 tons, why not do that? And digital twins and AI start with making the physically digitally. So basically, you still need the feed of data towards all these models to optimize an AI. And for me, it's just we have more computing power, and therefore the same equations we had 60 years ago are now actually being used much wiser. But you need to make the physical digital, and then you can start making all these great models. So I would say, for me, it's a no-brainer, and of course I will say that, but it's also what our customers say. And for the long term, it's ridiculous not to do it.
We've talked about gearboxes, planetary gearboxes, being able to sense the load changes on them. Slow rotating equipment. Okay, we've talked to a lot of people that test these things, and they're doing hybrid testing simply because it's so difficult to test, say, pitch bearings, rotor bearings, these kind of things, because they are slower speed. Can your technology be used for those types of applications as well?
Yeah, so that's where we are currently also in the development roadmap on the large, slowly rotating parts, pitch bearings. In marine, you see more of them, the ones which keep the cranes on place, etc. Slowing bearings, they're nicely called. But basically, those are hard to monitor because there's not enough energy to do vibration or to do sound measurements. And by changing loading or changing response of the outer ring, because that's what we are measuring, the deformation, you can see cracks, you can see uneven loading, you can see other issues. So we are able to predict failures much earlier than what's now ongoing. So that we are extending our, now I talk about a dream, are extending, if you have one optical part in it, you can do the blades, you can do the pitch bearings, the main bearing, the gearbox, the generator, probably the jaw, the pole, fully optical monitoring. That is, for me, it's the long-term goal to go there.
I'm gonna send some thought energy to a specific OEM here in the States that needs helps with pitch bearings. Call Eric and his team to get a project going so we can see the failure modes in these things before we keep cracking hubs out in the field. But Eric, I really want to thank you for the time today. If anybody has any questions about fiber optic sensing, slow rotating equipment, gearboxes, all the above, Eric and team are fantastic. How can the listeners reach out to you?
On my site, there's even my direct number still as a contact. So I'm via Sensing360.com. You can look at contact, and my number is there still. So that's the perks of being a small company. And LinkedIn, we're pretty active on LinkedIn. Is getting active on YouTube, but mainly via our site. That's how we are easiest to contact. Or you can do the simple one, Eric@Sensing360.com. That also helps.
Perfect. Thanks again, Eric.
Thank you. Thanks for having me.